So this is good morning. This is the derivation of natural frequency using Newton's second law. As we know, the Newton's second law says the acceleration of a particle is proportional to the displacement, but the particle having a opposite direction. That means the minus. So acceleration is proportional to the displacement, but the displacement is in the reverse direction. We have to give a minus sign. So then to remove the proportionality, we say x double dot is equal to minus omega square. This is omega square is a proportionality constant. Omega square is proportionality constant. Okay. Then this x double dot can also be written as d square x by dt square. Displacement double derivative is nothing but your acceleration is equal to minus omega square x. Okay. Now, if a object having mass m is displaced with a certain initial displacement and left it will have a motion. Right? It is called harmonic motion. So according to this motion, we know that the spring stiffness is K and it is displacing X. We also know K into X is nothing but minus M into A. The Kx is the force, which is spring force, which is opposing my inertia force. The inertia force nothing but M into A. That is why we say is a minus. So this is nothing but minus M is the mass of this object which is now vibrating. A is nothing but acceleration, which can be written as d square x by dt square. Is nothing but your k into x. Now substituting this d square x by dt square into the equation here, so what we get here, that kx by m, that is a minus, is equal to minus omega square x. So this x gets cancelled and negative sign will go away. This omega square is equal to k by m. So omega is equal to square root of k by m. Now the k is nothing but a stiffness of the spring. M is the mass of the object which is vibrating. So this omega is nothing but the natural frequency of the system. Omega, we call it as natural frequency. I'll repeat again. The acceleration, any object, a linear motion or a circular motion, the object having the acceleration, it is proportional to the displacement, but that is in the opposite direction. So to remove the proportionality of constant, we say there is a x double dot is equal to minus omega square x. Right? Just like we say the force is proportional to displacement. When I apply a force on the body, if a body is there, apply a force, it goes somewhere else with a displacement of x. So force is proportional to displacement. Then to remove the proportionality, we say force is equal to K times S, and the K is nothing but a stiffness, and that is a stiffness. So this x double dot acceleration nothing but d square x by dt square equal to minus omega square x. Now come back to the spring system, where if the mass moves x distance, the spring has force of k x. When this mass is vibrating, the inertia force, which is m into a, acceleration nothing but m into d square x by dt square, this is opposing the stiffness force kx. That's why we write minus. So kx equal to minus m d square x by dt square. Then substituting this d square x by dt square into this equation, so what we get here, the omega equal to root over k by m. Thank you.